Hi, this is Group 3's presentation on using code coverage to determine test adequacy. Our group consists of Anthony Campbell, myself, Devin Cenatiempo, Jessica Evans, and Jordan Parry. To begin, we will define and explain our topic. Then we'll speak about both the upsides and downsides of using code coverage to determine test adequacy, before finally talking about its effectiveness. First, what is test adequacy? Test adequacy is when predefined criteria has been met, which determines whether sufficient testing has been done. When this criteria has been met, testing can cease. Next, what is code coverage? Code coverage is a measure of the fraction of code which has been covered with an associated test. Code coverage is one way to determine the adequacy of a test suite. There are several ways to measure test coverage, and here I list 5 common ways to do this. First, we have line coverage. This is the simplest way to measure coverage, and it's simply the percentage of lines of code with an associated test. Next, we have statement or block coverage. A block of code would be a grouping of lines of code that allows multiple declarations and statements to be viewed as one statement. In many languages, a block is contained within curly brackets. Block coverage would be the percentage of blocks with an associated test. A decision or branch in programming refers to all the places in the code where decisions are made, usually a conditional statement like a switch or an if statement. Branch coverage would be the percentage of these decision-making statements with an associated test. The C in CUse stands for computation. CUse refers to 2 points in a program. First, when a variable is declared or modified, and second, when that variable is used in some computation. CUse coverage is the percentage of CUses with an associated test. The P in PUse stands for predicate. A predicate is a statement that resolves to either true or false. A PUse is similar to a CUse in that it is a pair of 2 points in the program. First, when the variable is declared or modified. Second, when that variable is used in a predicate. PUse coverage is the percentage of PUses with an associated test. Each of these measures can be used independently or together to determine test adequacy. For example, a company might mandate that there is 100% branch coverage and at least 60% line coverage. Then automated tools can run the tests and give a report on the code coverage for each of those measurements.
The first upside to using code coverage alongside test adequacy is that it produces greater effectiveness. A test case with a higher level of code coverage has been proven to have greater effectiveness at revealing failures in the implementation. Sometimes we measure the amount of code covered through a percentage, since it is unwise to define the amount of code coverage as simply good or bad. In practice, a percentage of code coverage is often used as an adequacy measurement because it more thoroughly specifies the amount of code that was covered. An upside to code coverage testing is that it gives the developers confidence in the correctness of their software, since an adequate amount must have been covered in order to pass the adequacy standard. A program is considered to be adequately tested if it has met the specific test criteria. For example, a specific test criteria could be whether all statements, branches, or data flow paths have been executed. Another aspect of code coverage is the visualization and analysis. There are programs that will collect code coverage data and create a visual representation of it. These visualizations can guide developers to a particular standard of effectiveness. Code coverage visualizations are designed to motivate developers to write more effective tests by visualizing test adequacy. In addition, code coverage visualizations are supposed to improve developer efficiency or promote more productive testing strategies.
There can be a downside when checking code testing adequacy. you run into the risk of testing too much or even too little. Obviously, the more lines of code that are written, the more lines of testing that have to be done. For every line of code that is written, it is said that 3 lines of code have to be written to test that code. Ultimately, there has to be a deciding factor as to when enough is enough. You do want to be thorough, and this can be very time-consuming. Even at times when an infinite amount of testing could be done, doesn't mean that it should be done. Taking a large amount of time testing can impede further production and even use up company time and resources, especially when the project is dependent on the adequacy of the test. Lastly, even though the proper amount of time can be calculated for testing, adequacy is not fully covered if the testing is poorly written. There can be a subjective line that has to be carefully examined when using code coverage.
Test coverage to determine adequacy is generally seen as a question of how much is necessary to be truly effective. Generally, people have calculated coverage by the number of lines of code divided by the test cases that are being executed. This gives a percent of how much of the code is being covered, but how does this relate to adequacy? According to measuring code quality with test coverage metrics, most people seem to believe anywhere from 65% to 100% is a good amount of coverage. This is a rather wide range. However, it is necessary to consider what it's actually covering. This is only the number of tests versus the number of lines of code. There is nothing to suggest the quality of the tests. Coverage is really only good for determining which parts of your code aren't being tested and which are. The next question is, what is a good test? A good test is generally one that traces a requirement directly. With this thought, testing becomes less about lines of code versus tests, and more about requirements traceability. However, this presentation and section are only on how effective coverage is in determining test adequacy. So, while it is a useful tool, coverage should not be the sole test of test adequacy.